Hello, folks. Welcome to Rational Science. We have a great day today. We're going to be talking about orbitals, quantum orbitals. What in the world are orbitals? Well, I've studied them for so long, and I must apologize that I have no idea. So you came to the wrong place if you want to know what an orbital is. But that's proof that studying does not give you knowledge. Okay, let's get started with what's going on in the world today. See if this is the year of extinction. Hopefully not. Hopefully we can all continue at least one more year. Okay, we got a lot of things going on. We got a couple wars, one in the Pacific, the other one in East Europe, and maybe we'll have a couple more. Who knows? It's going to be a fun year for wars. Okay, and the war that I'm talking about is Ukraine specifically. There's a lot of saber rattling, and people think we are going to go to war. The armies are preparing for one apparently for invasion, the other one for defense. And the question is, what is this war about? I like that from a movie. What was it, The Reds, where this guy was in Russia, in the Soviet Union, and he a newsman, and they asked him, "What is this war about?" And they thought he was going to give an entire speech. Warren Beatty. He just stands up and he says, "Profits," and then sits down. That's it. That's all wars about profits, right? Okay, so here's Ukraine. Here's the map. I showed this the other day. Okay, and what you got is the big bear there. That's Russia, known as the UFFSR, the Union of Fewer and Fewer Socialist Republics. Nothing has changed with Russia. All these countries today, they used to be part of the Soviet Union, most of them. And little by little, they've left the circle, the influence of the Russians, like Poland there and the Romania and so on. And then you have Ukraine there. You can see it's completely encircled by the Russians. The green areas, those are essentially in Russian hands. And there's a little region there that I marked myself. That's not really part of the map. I marked it myself. That's that green line that goes between Ukraine and a country known as Moldova. Okay, and that region, you might start hearing about it in the near future if there is a war, because those people there have formed a country of their own, and it's known as Transnistria. Okay, and here is a picture of that. It's that region there that I pointed out. Okay, it's a very long strip, thin strip, and all these people are really pro-Russian, okay? And they're right in between Ukraine and Moldova. And that might become a region that also, that they can put troops in there and might enter the picture. So you better look it up. Transnistria might be a participant if there is a war. But again, the question we should ask is, what is this war about? Okay, is this a war about, because you can see, Ukraine is completely encircled. Okay, so, you would think that, well, it's about Ukraine, obviously. Well, I can give you a different perspective. I don't think it's got to do so much with Ukraine. Okay, Ukraine is like the excuse. Okay, and I think this war is about something else. You had the First World War, and it was everyone against the Germans. And you have the Second World War, and it was everyone against the Germans. And this war is going to have a casualty, not Ukraine, Germany. This is the Third World War, and again, the victim will be Germany. Okay? Germany is going to be the big loser here. That's my feeling, that's my impression. Okay, Germany's going to be the big loser. No matter how Germany plays its cards, it's in trouble. Okay, because it's got a lot of dealings with the Russians and also with the Chinese, by the way. And the United States wants that stopped. Okay, and the Germans don't like that. Don't like the Americans imposing on them, telling them what to do with their business, especially when it's so vital to them. And I think this war has to do more with separating Germany from from this world in which they deal with the East, and putting Germany completely in the West. Another star on the flag, essentially. Germany and France. So in that sense, it's different than the First and Second World War. But I think Germany and France, they have a lot of dealings with the East, and I think the politicians in the West want that stopped. And so I think the casualty here will be Germany, and just time will tell if there is a war. There's another possibility. In fact, there's a couple possibilities as far as I can think. One of them is that maybe it's already in the works to try to overthrow the government in Ukraine. That would help some of these governments save face. They wouldn't have to choose sides, because if there's a change of government in Ukraine, and that government not necessarily has to be pro-Russian, it could be a little more even-handed. Maybe it's moderate, and it takes no sides, and it just stays calm. There is no war. And so if that happens, well, maybe everybody saves face, and there is no war. On the other hand, if the Russians don't invade, the Americans will say, okay, no problem. We'll continue putting weapons there and try to recruit slowly and slowly, see if we can get the Ukrainians to join NATO. Okay, so they're kind of forcing the issue on the Russians. And if, on the other hand, Russia invades, well, they lose Germany and France, because those countries will have a tougher time remaining neutral. And so I think if there's an invasion of some kind, I think Germany and France will lose. Those will be the big losers. And yeah, possibly Ukraine loses something, but nobody cares about Ukraine. Ukraine's not that important economically in the world, first of all. And militarily, it would help the Americans if they could put their troops in Ukraine and put it as part of NATO, but that's like a wish. And let me give you another dream, something that might happen, and that is, let's assume there is a war, and because of the war, the Russians economically start falling backwards, because everybody cuts ties with them, and so they lose a lot of business out there. So what happens? Let us assume that there is a coup d'etat in Moscow. Let's say they overthrow the anti-Western government. Well, that wouldn't be so bad. If you think about it, it'd be nice if the Russians were friends with the Americans, with the Europeans. We were all one big family, right? That's better than having these enemies there. Wouldn't that be nice if we all were friends? And then the only enemy would remain China. And maybe that would be a matter of time before China collapses as well. And on the other hand, there could be also a civil war in the United States, and that takes precedence over what happens in Europe. That's to think about. Okay, there are many possibilities, I think. Okay, moving on here. Fellow says, you cannot transmit. This is in relation to the moon, whether the moon landings happened the other day. Several people, in fact, had several things to say about the moon landings. This is one of them. And he said several things. I just picked up his fifth point there, because I thought it was the most important of the ones that he made, the one that can be analyzed, the more objective. And so he says, you cannot transmit live television from the lunar surface with the power output they had available in LEM 6. Okay, you cannot survive in a 0.00001 torr vacuum using a spacecraft developed in 1969. We have nothing even today that could withstand such a powerful vacuum. A lot of people think this way, okay? A lot of people out there believe that, we can't withstand the vacuum of space. We don't have spacesuits to withstand it. Other people talk about the radiation, that just zaps you, and that there is no way, a lot of flat earthers especially, the flat earthers, and they believe that humans can't go into space because of all these things. We can't stand the vacuum. We get zapped. Maybe the magnetic field affects us. Different things. And so they have this notion that we can't go into space. Okay, so first thing I want to show is the following for this gentleman here, who was a visitor, and it's this. He might want to do a research on this subject. I did quite a bit of it in the past. I do have the papers written by the people who made the Glenn Research Center, okay, and why they built it the way it is with the vacuum, that level that they achieve on a regular basis. And here it is. It says the chamber can reach a vacuum level of what? 4 times 10 to the minus 6 torr. Not very, not the highest of vacuum. It's called high vacuum. Then you have ultra high vacuum, which is above the minus 7 range, minus 7 torr range. Okay, so this is not ultra high vacuum. And the moon is at 10 to the minus 11, according to 3 of the probes that went out there and measured the vacuum level on the surface of the moon. And the solar wind is a little even thinner. It's minus 12 torr. So thereabouts. It's a very high vacuum, ultra high vacuum, what they call. And so the question is, why would they build this testing center in Ohio at 10 to the minus 6? I mean, the astronauts are going to go into the 10 to the minus 11. And so the couple of papers that were written when they built this facility explain all that. They said you don't need to test an astronaut at minus 11 level, minus 11 torr level. You do not need to do that. Already at minus 6, you will die. Okay? Please understand that first. You don't need to go to minus 11. So, and then the lack of pressure at minus 11 to minus 6 is not that significant when you're talking about humans, especially when they're covered by their suits. It's not like they're going to be exploding because suddenly you went from minus 6 to minus 11. High vacuum already is pretty good vacuum to test a human being. You do not need to take them to ultra high vacuum. But if you go to ultra high vacuum, there's very little difference from a health point of view from minus 6, minus 7 to the minus 11, minus 12 range. Okay, so all I can do is show you where to look for the information, and there are several papers written on this, okay, on this subject. But talking about that, let me get rid of this. Talking about that subject, here we have the Chinese, and they recently went out into space, and they're in the middle of space. What vacuum level do you think these people are experiencing there? Assuming you believe that this was not done in Chinese Hollywood, okay? These guys are working in outer space, okay? And or so they claim, so China claims. And nobody questioned that. The Americans didn't question it. The Russians didn't question it. Nobody's questioning that these guys were not in outer space. They do have, ways of detecting whether this is true or not, with telescopes and so on. These guys are working out there in outer space. And the question is, what vacuum level do you think these people are subjected to? And if they're in the middle of space, you're talking about, again, minus 10, minus 11, minus 12 range, torr, right? Range. And so, you really got to do a little more research on vacuum levels. And people say a lot of this. They maybe read something written by a flat earther maybe, and they say, oh, here it is. No, you got to do a little bit of research if you're really going to hold an opinion. And, I work with vacuum quite a bit. All I can tell you is, humans can with the suits on, right, can withstand -6, -7 level. And they did so all the way till the 60s. You know, they didn't send these guys out there without their clothes on. Even Gagarin, the guy who went around the Earth and so on, all these people were, you know, with suits inside their vehicles. So to say that humans cannot withstand that, you know, they do test them at this Glenn Center. They put a guy in there in this chamber, and they pull this thing down to -6 level. And you know, to say that he can't withstand it, even with the equipment we have today, with the suits we have today, it's ignorance. That's all it is. You gotta kill your ignorance. Go out there, do research, and you'll find out that yeah, that's with the suits we've got today, we can withstand the lack of pressure. You know, up to the -6, -7, -11 level, torr level. Okay, another comment on moon. A lot of moonies, lunars today, okay? Paul says, pseudoscience cultists will believe in such nonsense as the moon hoax because they are stupid, gullible morons, blah, 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 blah. Yeah, I mean, you know, the question is, did man go to the moon? And a lot of people out there don't believe it. And so they raise a lot of issues like, you know, what about this and what about that? And here I'll give you one fellow. He said the following. Let me remove this fellow here. This fellow says the following, okay? He says, I remember seeing the astronauts jumping around on the moon allegedly. Then recall that I was taught that gravity on the moon was something like 1/6 of what it was on the Earth. So I expected they would be jumping several feet off the ground easily. That's not what I saw. Really pretty weak jumps. And you can see it there. The guy jumps, but maybe a couple feet off the ground, you know, as he jumps around and falls back down. And so people say, see, this was done in Hollywood. Well, all I can tell you is the following. For all those people who believe in these things and these arguments, okay? Here's a list of arguments just pulled off the top of my head, okay? I didn't do great research on it. I just pulled it off the top of my head. And here it is, the errors of cosmic proportions, I call them, okay? No stars in the background. Some people say that. There were no stars in the background, so this was done in Hollywood or wherever. The flag waved, you know? Gravity jumps, as I just discussed, okay? Shadows cast by the astronauts. And I put a new one. I don't know if this is true, but I put that one in there. You know, the astronaut takes off his helmet. Okay, oh, that could have been done on the moon, right? And, you know, a lot of this, these conspiracy theories came out in 1978 with a movie called Capricorn 1, which I saw. I liked the movie. Not that I believed it, but it's a nice movie because it shows how these astronauts are removed from the capsule. They're put into a center, and they say, look, we got to do it without you guys because that vehicle is screwed up, and we're just going to send the vehicle out into outer space just in case so nobody gets hurt, right? And then bring it back, and you guys are heroes. You just have to act in front of the TV right now that you're on the moon, that you're on, this was a Mars expedition, that you're on Mars. Well, the story goes that when the vehicle comes back, it explodes in space. So it's destroyed. And now they have to kill the astronauts because if they appear in real life, they say, whoa, weren't you on that capsule? Weren't you dead? And so a lot of these a lot of these conspiracies came, at least took a lot of force because of that movie. Okay, and there were a couple more movies after that with the same theme. And yeah, the issue that I raise against those arguments is the following, okay? And I just want you to bear with me a second. If Hollywood were to make a movie, okay? In fact, I think it happened, where the Romans are fighting, I don't know, the Greeks or the Germans or whoever, and the guy's with his sword and he's banging away, and suddenly you see that he's got a Rolex watch, the actor. You know, it screws the whole movie because the guy's waving there his sword and he's got a Rolex watch. Now, how would people in the movies look at that? A big failure. You know, that's of cosmic proportions. And so here's the question for you. Do you think that the people who made the movie of humans going to the moon, do you think they would have made so many errors? I mean, you would think that they're professional. At least they know exactly, how physics behaves out there. They know a lot of physicists and so on out there are going to say, "Oh, but hold it. How about this and how about that?" So if they made this movie in Hollywood, right, with all these errors, well, someone's got to be fired because you would think that somehow they would have cleaned all this stuff out before showing the movie to the public, right? In other words, imagine they allow this movie to go to the public with so many errors. No stars in the background, the astronaut not jumping high enough. Then you have what the shadows are not right. All this stuff that they find out, the flag waving. They wouldn't have made so many errors. The more errors people find, the less believable is their argument. Because what they're saying is that all these guys in Houston, NASA, who made this fake movie, to convince the public of something, that they missed all these errors. They're so stupid that the director of the movie just made so many errors, no one caught it, and they just passed it on to the public, to millions of people. So think about that. I mean, if you find one error, some minute errors, well, they could have missed this. The director didn't see that there was this pebble on the ground that wasn't supposed to be there, or something like that. But to say no stars, the flag wave, the shadows are wrong, and blah, 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 and the jumping is wrong. If there's so many errors, you have a problem, not the movie. There's something you don't understand about physics. Okay, that's my 5 cents worth there. Okay, another fellow, I think along the same line, says, does the moon revolve around its own axis? Tesla did not think so. And there's Nick, good old Nick. And essentially the moon doesn't revolve, it doesn't spin. What it does is always shows the same face towards the earth. And don't be fooled by the bright light on the moon that's rolling around. Look at the arrow. The arrow tells you that the same face is being pointed towards the earth at all times. Okay, the light that you see there, the light shadow, that's from the sun. Okay, so the moon always shows the same face to the earth because it does not spin. It's what is known as a synchronous satellite. Okay, so Tesla was right on that issue. One of the few things he was right about. Tesla was not a scientist, by the way. He was an inventor. He was a technologist. He was a lab boy. That's all he was. And he invented some stuff, patented some stuff, got into a big war with Edison. One guy with Westinghouse, the other guy with Edison, was going to be General Electric. And apparently Tesla lost a couple of his arguments, a couple of his patents. Marconi outbid him, won a case against him. Then the U.S. government brought a case against Marconi and won against Marconi, saying that his patent was not valid. They said that many years later, after he had already won the Nobel Prize and beat the hell out of Tesla and so on. So yeah, it's a great world. You got to look at that whole story. It's really funny how all that history turned out. Okay, here's another issue. Fellow says, black-eyed babies stronger than other babies, may be new mutations, a new human species. Very strange things happen. Some people believe that we're going to continue evolving, and who knows into what? Maybe into robots? What can we expect in the future? Or are we it? Are we as perfect as we will ever get? And that's my 5 cents worth on that. I'm saying we're already there. We're as perfect as we'll ever be. We have all the intelligence, the maximum intelligence that Mother Nature, God, the devil, and all of them put together, Father Universe, that they can give us. There is no higher intelligence in the universe, in heaven or in hell, than the human mind. This is it, guys. I know you believe in super intelligence, something out there. No, no, this is it. We're as intelligent as there is anything in the universe. We have the ability to reason, to understand whatever God, the devil, Mother Nature, Father Universe wishes to teach us. Okay, so if one of these fellows, supernatural beings, comes over here and teaches us something, we have the ability to understand it. And that's as intelligent as it gets anywhere in the universe. So if you're looking for more intelligence because you feel that you've been gypped, you got it wrong. This is it. It doesn't get any better than us. Okay, that's the maximum the universe can give you. So all those people who think about super intelligence and that there's some being out there that have super intelligence and they can come here and show us all their technology, which is mind blowing and so on. Too much Hollywood movies. Take a break. That's what I say to you. Okay. Okay, here we have a fellow talking about climate change. Says the reality of climate change. Is the ozone layer actually trashed? The sun is definitely much hotter on your skin. Winters are warmer. I don't know. He probably has never come to Germany because it's been cold here this whole year. We haven't seen the sun. It's just been ridiculously cloudy. Is methane rapidly releasing from Siberia and other ocean floor? Permian, I guess. He's looking at that. Is this a rapid warming? Is this a rapid warming before grand solar minimum, or some other mechanism puts us into an ice age? And yeah, I don't think we're going to see an ice age like maybe 14,000 years ago. Those things take time, a lot of time, and a lot of it has to do with, again, pollution in the air. A lot of it contributed by humans, obviously. We're 8 billion people throwing garbage up there in the air, right? Among them, our own respiration every second of the day. So yeah, climate does change, and we do have some effect on the climate. In fact, a single human being already should be changing the climate. His tiny grain of sand, but he's contributing to the beach. Just by breathing and exhaling, he's already changing the climate. You may say, well, that doesn't change the climate much. Yes, a drop of water in the ocean, correct. But he's already changing the climate. And so does the climate change? Every second of the day. Every day, every minute, every second in the life on Earth, in the history of Earth, the climate has changed. So the issue is, should we be worried about it? And my answer to you is, why should you worry about it if it's a very, very slow process? By the time it happens, you won't be around for sure. And I don't mean necessarily because there's got to be an extinction, which I think will happen. But even if you last, if you're 20 years old, I don't think it's going to happen in the next 60 years. You're going to be 80 years old, maybe 90, maybe 100. And whatever climate change there is, it's not going to kill you, for sure. So I don't think you have to worry about climate at all. A lot of this climate change has to do with jobs, with creating jobs, and not so much with the danger to humanity. Okay, again, my take on that. So if so, is that mechanism natural, or have we done all this before? Yeah, again, I think it's a natural mechanism in the sense that every person contributes to climate change just by breathing. In that sense, there's not much we can do about it. We contribute to climate change simply by breathing. Okay, another fellow says they know, talking about the rich and filthy rich and affluent, they know they're not going to space, probably, unless they already have. And just don't tell us cattle that man has been traveling the star for some time. He thinks a possibility that the rich and powerful have already traveled through space, but they're not going to tell us. You know what I mean? Because maybe we all want to get on the spaceship and leave the Earth. So that just leaves running off to their underground cities and hoping to wait it out. And they have the gopher holes. People believe the rich and powerful have all these cities underground, and if we could just find them, we could join them there. Maybe Again, too many movies. That's the problem with all these people. They probably knew you didn't want to be around for whatever went down and just decided to go do something else with the time we have left. So a lot of people believe this, that the rich and powerful, the Illuminati, the New World Order folk, and the Skull and Bones, and all these organizations, secret organizations of rich people, and what they're doing is creating all these secret cities underground. They're going to go down there when the shit hits the fan. Uh, all I can do is tell you my 5 cents worth. It doesn't matter if people like Trump or Bill Gates go underground to their private city. Are they going to go down there alone? How did they build that city? Did they build that city by themselves with a little shovel, or did they hire a company to do the city underground? And of course, you would say that they probably hired someone, a lot of people out there to work underground, because you got to dig, you got to build the installations down there in the bottom floor, and then you got to live there. And the question is, Bill Gates going to live there alone? Maybe he takes lots of people down there with him, like to help out when things, when everybody on the surface is dead, so they can now come out of there. Well, the question is, what control does Bill Gates have over those people at that point? Because at that point, money is no more. What control does he have? Can he order them to do something and say, or I won't pay you your salary? No kidding. Yeah, I mean, once you're down there, you can't have people who are not part of your loved ones. Maybe that's a good way of putting it. I mean, if you're paying them, if they're salaried people who work for you for money, that deal's off once money is no more. So the rich people have no control over the people they hired down there to help them, or to be servants, or to whatever. And that's not counting the people they hired to make the hole, who know where the hole is and will say, oh, I want to go down in that hole because I know what that hole was for. And besides the fact that these people would spread the word right now and tell other people, oh, by the way, Bill Gates built a hole there in the middle of South Dakota. So this notion that all these cities are underground are people who watch too many Hollywood movies. Okay, going down under, right, is not going to help you survive if you're going to need people to help you. People you don't know, people whom you are paying salaries to. That's the first issue. Then the second one is to build that hole down there. Someone else knows, and that person's going to tell some other people, and so on and so forth. So we should all know where all these holes are right now. Okay. Now, could there be one hole, some person out there who did it? Yeah, it could have been. And again, that person has to watch out, because this is not a question of hiding. It's a question of securing your future. How do you secure your future other than with money? And if money is no more, what future have you secured for yourself? Okay, so keep all this in mind. You got to think this over. At least that's my line of thinking, my train of thought. Okay. Now the fellow says, isn't technology just a synonym of tool? In a way, yeah. That's what technology is. Manufacturing is tool, right? Innovations are not technology. Yeah, correct. And that's why I define innovation and invention. I separate these two terms. And I'm saying invention has to do with objects, whereas innovation has to do with concepts. That's essentially the difference. Invention belongs to physics. Okay? Invention is not how you do something more efficiently. Invention is a gadget that does something. And that has to do with physics. Okay, so I separate those two, and that's why we need to separate these two words, because only invention belongs to physics, innovation doesn't. Okay, and it says technological progress will slow down soon. Yeah, in fact, I'm saying that there's been no invention, no real invention since the computer. Anything else is just putting things together, like the smartphone. What is that? It's an all-in-one. It's all these inventions that already were on the books, You have a radio there, you have a television set there, you have a telephone there, you have a computer there, you have all in one. And on top of that, it's portable. That's what we always wanted. There is, and that's not an invention, it's just um, putting several inventions together. So we have no real invention today. The age of invention is over. Okay, whatever invention you see out there, maybe to make money, uh, it's cosmetic. It's minor. It's not a real invention. Like the telephone was an invention because it put people to work. The car was an invention. The airplane was an invention. It put tons of people to work because industries were built upon those inventions. People wanted to have those things. They wanted the airplanes, they wanted refrigerators, they wanted TV sets. And once we invented all that, we're done. We don't have any mind-blowing inventions today. Nothing, especially what I'm referring to is that puts people to work. Manufacturing is dead. Never will it rise again. I don't care what you invent today. You might make a buck, invent a pet rock, and you start selling. Say, oh, I invented the pet rock. Great. You make some money. You say, well, that's an invention. Yeah, I guess you could call it an invention. I'm talking about stuff that you can use that people want by the billions out there because suddenly, everybody needs one. We have all the things we always wanted. Now you want a better computer, yeah, they'll invent one. You want a better phone, yeah, you can have it. But a phone is a phone, and a TV is a TV, and a computer is a computer. Nothing's going to change that. You can't invent the chip again because the chip's already been invented, and so on down the line. So this notion that once we reach like people like Kurzweil say the singularity, there's going to be just exponential growth of technology. What technology? What invention? What are you going to? What is it that you need? What is it that you want in your life that's not already out there? I mean, maybe a machine that takes you to the fourth dimension. That would be an invention if you can make it through the fourth dimension. But a vehicle is a vehicle. I mean, what do we have? Flying cars? Is that an invention? People dream a lot and they watch too many movies and they don't have their feet planted on the ground. Manufacturing is dead. It'll never rise again. It's advanced nations, anywhere from 15 to 20% of their GDP and labor force is manufacturing and dying, slowly being smaller and smaller and smaller of GDP and of labor. So even if you invent, I don't know, something unimaginable, because people cannot even tell me what they would invent. Because if you can tell me, if you can dream, I'm not asking you to build it. I'm asking you to dream about an invention that doesn't exist, that people would buy by the billions. If you can conceptualize it, you're a genius. Okay, if you can conceptualize something that everybody wants that we need, we already have all that. All the stuff that we needed, we already have to make our lives comfortable. Okay, we have the couch, we have the bed, we have the table, we have the the stove, we have the refrigerator for a beer, very important in my place, in my life. We have everything we need. What else do you need? The kings of old, the pharaohs, they didn't have all this stuff. They didn't have toilets. They didn't have bathtubs or showers. We've got everything we need. We don't need anything else. That's why we're not inventing anything, because the guy who invents something today really has to go out of his way to really come up with an invention. That's how difficult it is to invent something new. Look at the gaming industry. What else is there? It's game after game after game is just the same game as existed before, just some minor changes, and there it goes. So no, there are no new inventions, and there never will be inventions that put people to work. Okay, that's the criteria. Okay. Fellow says, is it rational to debate history? Rational to debate history. For example, whether or not Mao killed people or whether or not we went to the moon, it seems irrational because it is all based on saw and heard. In other words, past tense, right? And all I can say is, science deals with two aspects. One is physics, the other one is philosophy. And I don't do philosophy here, but that is the other branch of science. And what does that include? Well, philosophy includes history. What is it? Well, you're trying to figure out why someone did something in the past. And again, like I said last time, I haven't seen Napoleon. I haven't shaken hands with him. And so does that mean Napoleon never was around? He never existed? I'm sure that in his day he was there. And how do I know that? Well, I know that because other people passed that information down to me. Like, they used to pass all these stories from father to son in the tribes and the old clans, and a lot of them filled with mythology again. But the deal is that's how they passed it on from generation to generation. And we invented something known as writing, and through writing we do it today. And so if you want to know what happened in the past, well, you don't have to hear it from word of mouth, which we do as well in school, but you can read a book and it tells you what happened in the past. And I don't mean that you have to believe, whether Washington, chopped a cherry tree or something like that. Maybe you don't want to believe that. But to deny that Washington existed, 200 years ago, that's a different step that you're taking there. Okay. So certain things you don't want to believe, but certain other, you're going to deny that Napoleon ever happened and that Julius Caesar never happened. So what are all these people writing about in the past? They pass this information continuously from one generation to the next. We got it today. You're going to say that Julius Caesar never happened? And so this is where I see the problem with the reasoning that these people have. They are throwing the baby with the wash water in this case, right? They're saying, look, I haven't been there, I haven't touched it, I haven't seen it, so it never happened. The nuclear weapons were never dropped on Japan. JFK never was assassinated because he didn't exist to begin with, and so on and so forth. No, at some point you got to draw the line and say, some things you got to accept because that is our history. And I'll give you a specific point, a good analogy here. We find, for the question this person asked, we go into the rock, to the layer of rock, and we drill in there and we find a bone. Turns out it's a dinosaur bone, big bone suddenly, and say, well, this animal doesn't exist today that has this head. And you say, well, maybe it's a fluke, maybe it's an elephant who had arthritis. Okay. Now you find another one similar to that, and another one, and another one. You find several of them, and you can't find these animals around. So they're history, right? Well, you got to explain that, especially the layer of rock in which they were found. You say, well, hold it, how much dirt fell on top of these guys? Well, 60 million years worth of dirt. And so this guy was buried way beneath. That is history of life on Earth. And so now you see this bone in the layer of rock. You pull it out, and now you got to explain it. And so in that sense, yeah, you got to. History does play some kind of role, at least in science in that sense. And for sure, in the same way, you can translate that into history and say, look, if I find a bone, like the other day they found the remains of Richard III, the King Richard III, who fought at Bosworth. And, they find a bone and they say, oh, we found a bone. They checked it out with DNA and they said they confirmed that's him. Likewise, they found the family, the royal family of Russia, the Tsar, Nicholas and his family. And so they get these bones. These people are not only around, but those bones belong to someone. It coincides with the history that we read. We have to say these people were there. You can't say, oh, I don't believe in the Romanovs were ever there because I wasn't there. I didn't shake hands with them. So yeah, history is part of science. The behavioral part, the why they did something, why they behaved this way, why did they go to this place, why did they not go to another place, that part is the science part. Okay, and so yeah, you can't just deny all of it and say, no, I'm not going to accept any of that. Okay, so Just keep all that in mind, okay? Anyways, let's move on to physics today. We're going to go with this issue of the orbital. Okay, what in the world is an orbital? We hear about it, we see it drawn. We have an illustration, we have an image of the orbital. Okay, and it turns out that it doesn't coincide with with what they're explaining, and they cannot justify that orbital. And so it all comes partly because a question that a person asked the other day, but I already had this on my things to do list. This is a question I just told them to take a rain check on it, okay? And so just keep that in mind. He says, could you explain how the different atomic substances, the elements, are accounted for in the rope hypothesis model? Very important question, very good question. And there you see the atomic orbitals, okay? And you can see they're all balloons, and you wonder what all those balloons are, okay? We're going to find out that those are regions in which you can find the electron beads. So these are regions, these are balloons, but you don't see them in the standard model. We don't see these balloons in there and say, well, this material is made out of, I don't know, whatever. And they call it this or that. No, these are supposedly regions. That's what they're supposed to be, regions where you can find the electron bead. Okay, so that's the overall notion of this thing called an orbital. Okay, and another fellow along the same lines, he asked the question. He says, make a video presentation about the pictures that we have of atoms. Aha. And so what is he referring to? Well, he's saying a lot of people argue against your views and rational physics because they have pictures of atoms. So they have pictures of atoms, and so they say, Bill, you're wrong. If we have a picture here, are you going to deny the picture? Okay, so that proves to them that the atomic theory is true. So first we attack those two words, proof and truth. Okay, those belong to religion. That means that you are convinced of something. What is true to you is a lie to your neighbor. Okay, so, to you maybe God is truth, and to your neighbor, he's an atheist, he doesn't believe in God, so for him, God is not true. And so to you, it's been proven, to him, it's not. Okay, so truth and proof are part of religion. They have nothing to do with science. Okay, in science, we have to be objective. And it's got to be an objective theory, an explanation of something. In physics, we explain mechanisms. Okay, so here is something that will clarify to this fellow about his question. He said he wants to see an atom. And this came out on June 28, 2021, not even a year ago. Okay, and if you look at the title, it says, see the highest resolution atomic image ever captured. This is the highest, this is the state of the art here, fellas, okay? And it was, again, less than a year ago. And it's this compound, okay, it's some metal there. And it's got praseodymium, scandium, and oxygen. And these are different elements. And there you have the atomic structure. In the case of praseodymium, it's got 59 protons and 82 neutrons in the center, in the nucleus there. Scandium has 21 and 24, and oxygen 8 and 8. And there you can see the structure in the upper right of what you're staring at on the bottom right. Okay, and I've identified there, the praseodymium, the scandium, and the oxygen you cannot even see it because it's so small. Now, this is the best image, the highest resolution atomic image. Okay, that's the first thing you have to note here. And the question there, can you see the orbiting beads? Can you see a single electron orbiting the atom? And the answer is obviously no, you can't see it. You can barely see the biggest of these atoms, which I showed there, I have identified there. You can barely see that from like a bird's eye perspective. And certainly you can't see not only the little beads going around, but certainly you cannot even see the nucleus, which has, again, in the case of praseodymium, 59 and 82. Okay, so you got 141 nucleons in there. Okay, and so you got 141 of them, you can't see one. Yeah, because again, this is seen from a bird's eye perspective. Okay, if this is the highest resolution that we could ever have, then clearly we've never seen a hydrogen atom, which is much smaller. We haven't seen an electron, we've never seen a proton, we've never seen a neutron. We've never seen any subatomic particle because we cannot see even atomic particles. Okay, this is the best we've got. Right there, you see it there. Okay, now I want to show you something, because how did they determine that picture there? Okay, did they take a snapshot? They say, oh, here's a snapshot. Now let me show you how they determine this. Okay, and here it is. It's known as tychography. Okay, and this is the process of how they detect these things, how they take pictures, images. It's not even a picture, it's an image, right? A computational method of microscopic imaging. Okay, that's what tychography is. It generates images by processing many coherent interference patterns that have been scattered from an object of interest. So they play around with certain lighting, certain images, and from this composite they make, one image, and that's what you're seeing there. And what we just saw is something from a bird's eye perspective. Okay? So they construct this little by little, like piece by piece. And the best they can do is what you see there at the bottom there, again, a bird's eye perspective of this film. Maybe you can see individual atoms from far away. That's it. That's the best you got there. This is the highest resolution we ever could attain. Okay? And so it's interesting because, what was it, in 2008, you had a group of Swedes, university in Sweden, and they claimed to have filmed an electron, and it was put throughout the world in almost every scientific news or outlet, right? And here it is. That's what it looks like. Here's one site that put it out, named Photonics. Okay, and what they say here is that, again, that they filmed this electron bead. And it said there, an electron's rapid motion has been filmed for the first time, with attoseconds laser pulses showing how an electron rides a light wave after being separated from an atom. So they're claiming that this is a single electron that they were able to film. And part of the problem here is that you can see that you see some little lines there. So it's like this electron is made out of parts when it's known even today, defined today as being a particle, a point particle that can't be seen, that doesn't take up any space, and which is not made of even smaller parts. And here you see all those issues violated in one picture. Not only is the electron identified, it shows you what it looks like. It's some kind of ball, some kind of circle, okay? And it's made out of parts. So we got a problem, because on the one hand, they tell you one thing, that no one can see an electron. It's so small, they don't even know if it has any size whatsoever. They call it a point particle. They say it's got zero size. Some people say, well, it's just we can't see it, but there's two versions of that. And here they say it's something totally different. They even filmed it. I wonder when these people are going to gain their Nobel Prize, for having filmed the electron. But it says there, until now, it has been impossible to photograph electrons, since their extremely high velocities result in blurry pictures. The movie of electron motion was created by scientists, etc. Their method involved using a stroboscope and a laser that generates the extremely short light pulses needed to capture the movement of an electron once it is pulled away from an atom. Okay, so you figure out. These people are contradicting themselves constantly. On the one hand, they say, look, the best image we could ever get is this compound, because it's not even an atom. They had all these atoms within that compound. It's a bird's eye perspective. It's got 141 nucleons in one case, right? The other one had but 44, I think. And you cannot see a single one of those nucleons. What you see is a bird's eye perspective of the whole atom, which does not look like beads going around. It looks like ball. And it turns out that each one of the nucleons is at least 1,800 times bigger than the electron, which these people claim to have filmed. You figure out, okay? I think these people are just getting their names in lights. It's known as a scientific lie. It's a fib. Okay, so what's the issue today with this orbital thing? Well, again, we haven't seen any of these atoms, but as you saw just a minute ago, the orbital of those atoms, we saw them from far away, and they all look like balls. They all look roundish. They all look like balls. In fact, every time you see an atom being, like they say, we took pictures of an atom. Every time you see those atoms, they all look like balls, round balls, all of them. Okay, and so here, I showed the other day, you have the proton and the neutron. Okay, one has 2 up quarks and 1 down quark. The other one has 2 down quarks and 1 up quark. Those are those red and blue things inside that sphere. Okay. Now the question I asked the other day was, look, okay, here you have these 2 entities, right? These 2 particles, and why did they draw them with that sphere around it? Why didn't they draw it, for example, like this? Wasn't it supposed to be like this? Because what is that sphere? You know, are they putting that in by hand? You know, what is a sphere? I mean, let's take all that stuff out. Let's just leave the sphere now. There we have the sphere. What is that sphere that encapsulates the proton and the neutron? And again, you won't find it anywhere, identified anywhere in quantum dome. You'll never find what this is. So they put it in by hand. They just make believe. Why? Because they want to show that the quarks do not leave the proton or the neutron. They don't just spontaneously fly away. And so if they're encapsulated in this sphere, then people understand just by looking and say, well, I see why the quarks don't fly away. Not only are they bound together by these glue-on springs, but on top of that, they have all this sphere within which they're trapped. They're in prison. Okay? They can't leave this spherical prison. But they never identified that spherical prison. That's the issue. What material, what is that? Just name it. Give me a name for it. And they call the whole thing the proton or the neutron. Well, we have a very similar situation with the orbital. In fact, it's almost identical. One is an analogy for the other. Okay, and here you see it. Okay, here we have these balloons, and all these balloons that you'll see out there, these are the orbitals. And you say, okay, what am I staring at? What are these balloons? In fact, in regular chemistry class and physics class in college, they simulate them with balloons, with actual balloons. They say, look, imagine this balloon like this balloon like that, and they play around with the balloons. The teachers, the instructors, they play around with the balloons to show you how the atom is constructed. They never use, the little particles flying around. They can't do that, because they can't simulate like the hydrogen atom with a proton in the center and the little electron bead flying around, unless they somehow tie that electron to the proton. They could do it if they had a little string or something, but without that string, they can't simulate the electron going around the proton. But here, what you're seeing, all these balloons, they're supposedly the orbitals or energy levels, and yeah, they do simulate them with balloons, and that's exactly how you see them there. Okay, so what are orbitals? Someone asks you, they're balloons. Okay, that's what they are. Okay. So let's make sure that we understand. Every time you think of orbital, you have to think of balloon. Okay, that's what an orbital is. Okay, so here you see the hydrogen balloon on the top. Okay, and you see that blue electron bead rolling around the red center, which is the nucleon. In this case, is the proton. There's no neutron in the ordinary hydrogen, right? You got to go to deuterium. It's got one neutron. Tritium has two neutrons. But the standard hydrogen has no neutrons. So it's just a proton and an electron bead going around. But as you can see, the electron bead is not tied by any string or anything to the center ball. And so the question is, what is that blue sphere within which the electron is trapped? What they explain, what they always, whenever they have to use, for example, the hydrogen atom to explain something, for example, like electricity, even though you can't do it with hydrogen, but just for the sake of simplicity, let's assume you do electricity with hydrogen atom. What's moving, according to them, is one electron from atom to atom. And you can understand that if the electron bead is just rolling around the nucleus and nothing is tying it to the nucleus. You can imagine that electron bead just going out for whatever reason, whatever pushed it out or whatever pulled it out, and going from atom to atom. But the question is, that's the atom that they explain, that's the one they use for electricity, that's the one they use for ionization. But then when you ask them, okay, so what does the atom really look like? Well, they say it looks more like a cloud, and what they draw is that orbital, that energy level, the blue one, and it's nowhere to be found. What is an energy level? Well, it's a region within which you can find the electron bead. That's all it is. If it's a region, it's a concept. I'm talking about, is that a membrane? Are we staring at a membrane or some kind of sphere, that solid that the electron for some reason cannot escape? What is that blue thing? And you won't find an answer to that question anywhere, because they talk about math. They start talking to you about abstractions. They say, well, you got to study math in order to understand what that is. No, if you're going to draw it, if you're going to illustrate it, you got to name it. And if you're going to say that it's a concept called energy level or orbital, which is just a bunch of orbits of an electron bead, which means that within that region you can find the electron bead, a region is not a physical object. You can't say a region, knock my wall down. The word region cannot be used as a physical object. And that's what that is, just a region, that for some reason the electron cannot escape. And then, the electron doesn't fall to the nucleus either, so there's something preventing the electron from falling to the red ball. And so it's all screwed up. The whole picture is screwed up, okay? But that's how the orbital is conceptualized, as some kind of sphere that surrounds the proton, and the electron bead is trapped within that sphere. For some reason, something pulls that electron out, and now it can start flowing in the case of, higher level elements like iron and so on, and now you have electricity. First ionization, now electricity. But so the electron bead has this possibility of going into the conduction band and start flowing. And you say, hold it, how did it escape the sphere, this orbital? And again, they say, well, it's the energy. You have to pull it out with energy, whatever energy is, that's another concept. So we have concept on top of a concept. We have concepts interacting with concepts. That's all we have, okay? That's important because if you're going to do physics, hopefully you don't do it with concepts. You do it with physical objects, okay? Okay, so where did all this start? Well, we can take it back all the way to Mr. Democritus. He's one of the champions of the indivisible, known also as the atom. Something you can't cut. And he was a student apparently of Leucippus, and they were both, they weren't really Athenians. I put there the Parthenon, but they were up north, even beyond Macedonia. Okay, so they were on the other side of what was known as Greece, but they were part of the same culture. Okay, and yeah, they came up with this indivisible, and they were criticized by people in Athens later on. Couple hundred years later, by people like Plato and Aristotle, who analyzed what Democritus said. But Democritus said something more or less correct, which is there is only atoms and empty space. The rest is just pure nonsense. Okay? More or less, that's what he said. Okay? Okay, it turns out that we had to wait many, many years, 2,000 years almost, for there to be an improvement over Democritus's atom. Okay, it was tackled at the beginning of the 19th century by Mr. Dalton, and some people say he plagiarized uh, what others had already done, but this is about the best we have. And what Dalton essentially proposed in 1803, I think it was, he proposed that there were different elements that had different types of atoms. And he didn't know what they looked like, but he just drew them differently so that people would recognize that these atoms were all different. Okay? And so he built his first, you could say, periodic table. That's the most fundamental one that we had, the first one. And again, this was the first time since the days of Democritus that we had notions of what an atom was. And what these people are saying is that atoms are different. It's not that all atoms are alike, like Democritus suggested, they're all little balls. Dalton and his generation were saying, there are different levels of atoms. They look different. If we had God's eyes, you could see in there. And I think he drew them more or less the same, except that he put a little cross here and whatever, an X on another one, and so on. So he made cosmetic changes because he had no idea. He was just saying that they're different because they had different weights, they had different reactions, and he noticed that in the lab. He was a chemist, and so he noticed some of these differences, and eventually this notion surged from his generation. It wasn't only him. Okay, but he wrote about it, and we won't see much of an improvement again until we get to Mr. Thomson also, and for the atom. And what he suggested is the atom, especially the hydrogen atom, right, was some kind of what they call the plum pudding model. They had this positive ball sphere, and they had all these little negative beads somehow meshed in there. Okay, they were floating around in this cake. Okay, this was the first notion of what a hydrogen atom could look like, possibly. Okay, and of course it didn't stop there. A couple of years later, in fact, not too long after that, about 15 years after, Rutherford and Bohr, they came up with the planetary model, looked more or less like this. Okay, and they were able to, I guess, explain electricity in these terms as well. Other people in that age, they figured out that the electron was moving from atom to atom. Okay, but this was their atom, their hydrogen atom. Okay, later on it was modified just slightly so that the quarks in the center, we saw that the other day, the quarks in the center were invented or put in there by hand, like we talked the other day. So now we had these quarks, and they were kept together again by some kind of membrane and by the gluons that pulled them together. And those are the springs that are helping these balls bounce back and forth against each other. But essentially this was the atom, a little bead, the planetary atom, a little bead going around the nucleus. Okay, solar system type atom. Okay, suffered a couple more modifications in the 1920s. Roaring 20s, and here you have two people who worked on that. One was Louis de Broglie, he was a French guy, and the other fellow was Max Born, okay, German fellow. And one guy said, look, we have these integral waves, and the electron is really spread around, okay, around the nucleus. Born came up with the cloud model. He wasn't, again, these guys had other people working at the same time. These are just the highest honchos that worked on these things, the guys that were given the credit for a lot of this stuff. And what Born did, he came up with a cloud model. He said, well, the electron is really distributed all around the nucleus. And so now you have what is developing here is the cloud model. In other words, the orbital, because what you're staring at there is this orbital that's coming into, is being born. Okay, I guess that's why his name was Born. It was being born because originally you had the planetary model. De Broglie says, hold it, it's not really a circle, it's a integral wave, you cannot imagine why the electron bead would go in and out to form that integral wave. Okay, because if the electron is a bead, why would it go back and forth? Maybe it's a hula hoop that goes all around. And now Born is saying the whole nucleus is being encapsulated within a cloud. A cloud of what? Well, a cloud of electrons. What do you mean a cloud of electrons? Well, all these electrons are moving around, they form like a cloud. Oh yeah, but the hydrogen atom has only one electron. And so they had to come up with a notion that the electron is everywhere at once because it behaves like a wave, and a wave is everywhere, etc., etc., etc. So this electron, which is a little bead, suddenly covers the entire atom like a membrane, like a ball, like a sphere, solid sphere, in fact, because the electron cannot fly out. Okay, so this is how these notions were developed, and they did a lot of math, a lot of equations to show that that was the case. And the number one guy there was Schrodinger, the guy who invented the dead and live cat, right? And so Schrodinger equation, that's an important equation in quantum, probably the most important one. And what it does is it calculates the evolution of the wave function over time. It requires three quantum numbers known as N, L, and M, and to specify a wave function for the electron. And there you see it at the bottom, how the wave function is moving through time, right? Quantum numbers provide information about the spatial distribution of an electron. Okay? What are these people talking about? What is this equation? What does it do for us? And what it does, it maps these so-called orbitals, these energy levels. It tells you what this looks like. Okay? That's essentially what these people are talking about. They're going to map the atoms, okay? And so you get to this point where here's the quantum version of what these people are talking about. And these are the quantum numbers that are included in the Schrodinger equation. You have the N, L, and M. The S is not part of it, but it's the fourth quantum number there, but it was not included in the Schrodinger equation at the time. But what is this? The N is the distance from the center of the nucleus to the electron bead. Okay, it's that distance. The azimuth or latitude the electron bead has along the orbital shell. That's what the L is. And the M is the longitude. Okay, so you have latitude, longitude, and essentially the distance from the center. That's what the equation essentially does. If you put that in there, it maps out the region in which an electron is trapped. Or you could say the region that the electron draws or illustrates, paints, okay? Under the rope model, we use those same numbers. We have no problem with Schrodinger's equation, except that what we're talking about is not an electron bead that's going around. We're talking about a membrane, just like we just saw with all these pictures where they show a membrane. And that's exactly what the rope model proposes, that they are, in fact, membranes. What is the N? It's the radius of the electron shell. It's not the distance from an electron bead to the center. It's the radius of the shell. The latitude is the location along the shell, and the longitude is a location along the magnetic thread. Okay, so we can use the same equation, okay, that Schrodinger had, except that with that same equation, what we're actually doing is mapping the sphere, not the orbital, not an abstract orbital, but an actual membrane that encapsulates the proton star. Okay, so we have no problem with Schrodinger's equation. I think it was a good effort on the part of Schrodinger. You know, one of the first persons you do want to take your hat off for coming up with that equation, because it helps us map the electron shell. And again, it's they called it a cloud, they call it a shell, they treat it as a sphere, and then they deny all that. Say, no, it's a little bead, and what you're talking about is a region. And then they have all these regions interact. They get rid of the little bead, and they just have the regions interacting. They have two concepts, you know, interacting. It's like a region of space with another region of space. There's nothing there, and the regions interact. So again, they're dealing with abstractions, okay? They're not dealing with physical objects. Okay, and so here we have the rope model of hydrogen gas, H2, two hydrogen atoms, and what has happened is the membranes have fused. Okay, that's what's happening. And again, these things are spinning, okay, and that's how they merge into each other. Okay, ours looks like the true H2 gas molecule. Here it is. You can see that the H molecule that they paint is the one at the bottom, two H atoms that are merged in some kind of figure eight, and they treat those membranes, those orbitals as membranes. They treat the energy levels as actual things, and that's exactly what we're saying. We're saying that what they're actually representing there is two atoms that have their membranes fused. Okay, so we're consistent with what with the orbital notion, but the orbital is not a region. The orbital is actually a membrane. Okay, in contrast, here we have the quantum version. They show the one on the left, but that's not the one that you see in the standard model. The one you see in the standard model is the one on the right. You see a proton and you have an electron bead. And that blue circle, those two blue circles, what are those? Well, those are supposedly the regions in which the electron bead can be found. And of course, that's the two-dimensional version. When you have the three-dimensional version, you have the one on the left. And they do that. You can see that they forget about the electron bead. Now they're merging the membranes, which are not membranes according to them, just regions. For some reason, those regions merge and form a bigger region. Okay, so again, it's lying. That's what it's called, scientific lying. Okay, they're lying because they're not showing what they're saying. What they say is the one on the right, and what they show is the one on the left. And you ask them, well, what are these regions? Are they physical entities? Because they're merging. Obviously, they're talking about a membrane of some kind, which is what the rope model says. And that's not what they explain. What they explain is the one on the right. Okay, so keep that in mind, how what they say doesn't match what they illustrate. That's what I'm saying. Okay, so here are my conclusions. Okay, the quantum orbital essentially is many orbits. It's what they're saying is that's where you can find the bead. If it's not orbiting, we don't care. What they're saying is that's the region where you can find the electron bead. And they put all these together and they say that's an orbital. And what is that really? Is it the location where you can find the electron bead? They don't care about that either. What they're talking about is energy levels. They're saying that this energy, it goes from this energy level to this other energy level. And within that, those two energy levels, whatever that is, we can find this region, and we're going to call that region an energy level or an orbital. Okay, and for some reason, the electron bead, in case of the hydrogen atom, can't fall to the atom, to the nucleus. That means there's some kind of region, some kind of barrier that prevents the electron bead from going south also. So you figure it out. So what is an orbital? A region where the electron bead can be found. Okay, region is treated as a rigid membrane for binding atoms into molecules, right? You have all these regions, they merge, they form molecules. And the H2 simulated with regions, okay, not with orbiting bead model. They forget about the bead when they're making these shell models, these region models, these orbital models. They forget about the bead completely. They just deal with the orbital. Okay, and you say, well, what are you talking about? Well, I'm talking about a region. And what is a region? Well, we don't know. The E bead, the electron bead, can't escape the region. For some reason, it's treated as a membrane again. I mean, if it's a region, why can't the bead escape the region? And no, they treat it as a membrane. They insinuate to you through illustration that you're dealing with a membrane, and somehow the electron bead cannot escape that membrane, that wall. So they turn the region into a wall, into a sphere. Okay? Under the rope model, the orbital is a membrane. Very simple. And there is no bead, so there is no bead to escape. Okay? And here's the model that I put for the orbital for the quantum model. Okay, there you see it. Okay, that's the orbital. those are the different levels, energy levels, and I guess the eggs cannot leave their energy level for some reason. Okay, there you have the quantum orbital in a nutshell. So yeah, all you can figure out here is that there is a difference between what they illustrate and what they talk about. They explain something different. They describe something different. They say that we have an orbital or region, and somehow that region turns into a membrane. That explains why the electron bead cannot escape, because it's not a region, a concept. It's an actual membrane, a wall that stands in between the electron and freedom. And then, for some reason, these electrons are able to go into the conduction band when they are ionized by some external force. And what's the external force? They say it's energy. Whatever energy is somehow pushes or pulls them out. And that's when they start flowing. That's in a nutshell the orbital for you. Okay, let's go to some of the questions and comments people made. Here's one fella, and he says, oh yeah, this is the one I couldn't get to see the other day. I don't know why. Anyways, now I see it there. It says, to calculate the number of atoms in a sample, divide its mass in grams. Okay, so first you got to figure out the mass, okay, before you can calculate the mass. Because you got to weigh it. Okay, so first of all, mass is not the number of atoms according to him, right? Okay, because he says mass in grams. So, and he says to calculate the number of atoms in a sample divided by its mass. And so that means that the number of atoms is not the mass, according to him. That's out of his statement there, okay? And then you got to weigh it. You got to weigh the mass to find out how much it weighs, and then you do the calculation. Okay, so we have a dog chasing his tail. He's running around in circles, okay? By the same atomic mass, by the AMU atomic mass from the periodic table, then multiply the result by Avogadro's number. Yeah, no matter what you do, then you have to state your result for mass in quantity of atoms or whatever. You know, he says Avogadro's number, that's fine. We don't care. But it's got to be a number. It's got to be a integer. It's got to be an integer. In other words, you got to say this thing has 1 trillion atoms or whatever, 1 trillion whatevers. 1 trillion units of mass. That's how you have to specify mass. You can't say it weighs 1 kilogram, because then you're talking about weight. And if I have to, and like he says there, again, chasing his tail around, he says number of atoms. Okay, that's number of atoms, but number of atoms is not mass, because to calculate mass, you need to weigh it, and it's in grams. Then you have to perform a calculation to give you number of atoms. And once you have the number of atoms, you don't specify mass in number of atoms, you specify it in terms of grams. So again, it's just chasing his tail around. That's all they've done all these years. And yeah, and then we have another problem there, which is a secondary problem, which is, you know, if I weigh it on the moon and I weigh it on Mars, I'm going to have different results for the weight. The weight that I'm going to be dividing by Avogadro's number or whatever, okay? And so, you know, I'm going to get a different mass for each one of these planets, because that's the weight of this ball in different planets or different celestial objects. So if it weighs 100 kilograms here on Earth and I weigh it on the Earth, on the moon instead, I can't perform the same calculation that I perform in Mars, okay? So again, you know, this method of calculating mass, it's relying on weight, and weight changes from planet to planet. Okay, so there's several problems with that definition, that notion of mass. Okay, and really the best way to show here is that, you know, weight is in kilograms. We state weight in kilograms always. People say out there, well, that's the one in ordinary speech. That's the common notion, the ordinary notion. Fine, great. What is it in so-called science? Physics. What is mass in physics? And they say, well, it's quantity of matter. Okay, then why did you specify it in kilograms? First problem. If it's quantity of matter, give me a number, a trillion atoms, then that, or a trillion units of mass or whatever. Then we would have mass, because that would match the definition, which is quantity of atoms. No, they don't give you quantity of atoms. They give you a measurement, which we identify in ordinary speech with weight. Great. Now this fellow says, well, you got to take that weight and divide it by, make a calculation there, and now you're going to come up with number of atoms. Great. I come up with a trillion atoms. Why didn't you say the mass is a trillion atoms? That would be the same here on the moon and in Mars. No matter where, it would be a trillion atoms or units of mass or whatever. You would have a number. That's not the way they say it. They say it has a mass of so many kilograms. So yeah, they're chasing their tail around. Okay, they never figured out the difference between mass and weight. And there is no difference, because the way they determine mass is by weighing. And so there can be no difference. If I take a kilogram of whatever from the Earth to the moon, well, it no longer weighs 1 kilogram. Great. And they say, well, the weight changed, but not the mass. Well, how do you know the mass didn't change if the way you determine mass is through weight? And now we're going to weigh it on the moon, and how are you going to calculate the mass? And if I take it to Mars, all bets are off. So yeah, they have a problem. They can't say that the mass did not change, because it did change, because we determined mass through weight. That's why it did change. Okay, fellow says, if I can get it in here, says, the day science, this is from Nick Tesla. Poor fellow. Yeah, here he has said something very stupid. And he said, the day science begins to study non-physical phenomena, it will make more progress in 1 decade than in all the previous centuries of its existence. So he's saying that physics is about abstractions, which is the antonym of physical. Physical and abstraction are two different things, are completely opposites. And he's saying that it's got to be non-physical. It's got to be abstract in order for it to be physics. That's what Nick was saying here. Anyways, this fellow continues. He analyzes that. He says, in physics, physical quantities are all those quantities which are physically present. Okay, so I put a 5 there. I guess that's a physical quantity. And there you have a non-physical quantity. Why? Because it's a 0. And it's non-physical quantities are those quantities which cannot be seen. And you say, well, Bill, but I can see the 0. I can see it there. Yeah, but see, you're supposed to understand that the 0 represents nothing. So you're not supposed to see it. That's why it's a non-physical quantity. So a 5 is a physical quantity because you have 5 apples, but the 0 is a non-physical quantity because it's got 0 apples. I guess that's his reasoning. Okay, so that's kindergarten physics for you. Now let's do a little more advanced college physics. My God, some poor people. Okay, here it is. Let's see, this fellow says, Bill thinks reality is real. And there you have Mother Nature. Okay, and she created 2 kinds of humans, I guess. I would say, this is a number off the top of my head, 90% of people are spiritualists. They believe in all kinds of nonsense. And only 10% are really materialists that believe or sense that the universe is material. Democritus, only atoms and empty space. Yeah, that's essentially it. Okay, in between you have the ropes. He couldn't figure that out then, but essentially he was correct. Everything is matter that exists, because that's the definition of the word exist. An object that has location with respect to other objects. Okay, so then exists. So you want God to exist? No problem. God had better be tied to the, to the network, to the rope model. Okay, all atoms should be connected. He should be made out of atoms as a minimum. Otherwise, God doesn't exist by definition. Okay, and yeah, 90% of people are spiritualists, and they believe like this guy that reality is real or that reality is not real. So let's correct him. Let's show where he misconstrued what he said there. And here it is, a real object. What we do, by the way, is we define these terms so that we can talk intelligently. Okay, So we have to define what reality is and what real means. We have to define these words if we're going to make a case for them. And real is an object with location. There you have a definition. You don't like the definition, you have to put another definition there to counteract it. But that's the definition that we're going to work with. That one stays until someone can knock it down and show that there's something irrational about it, and they have a better one that they can defend. Okay? And then whatever is not a thing cannot qualify to be real, according to that definition. If it's not an object, it cannot even fit the definition of real. What is reality? It's not a substance. Reality is a concept. There's no physical standalone object called reality. I can't bring reality and put it on the table and say, this is reality. Okay? So reality cannot be said to be real or unreal. Okay? The word real requires an object. Reality is not an object. Period. We're done. Objects can be said to be real if they have location. If it's a concept, it's for sure it cannot have location, and therefore it makes no sense to say that reality is real. Okay? Again, a lot of this is because people use words of ordinary speech. They bring them into science, physics, right? And they try to make a case using ordinary speech. They never define these words because they think that everybody knows what they mean. And it turns out that in the last 10,000 years, no one defined the word real, the word exist, synonyms, right? And they never defined the word object. And so, yeah, that's where they lose. The word object destroys all religions. Okay, once you define that word, all religions fall down because it's a materialist word. Okay? You have to be a materialist to understand the word object. If you're a religious fanatic or a spiritualist, you'll never understand the word object because it destroys your religion. It's just that simple. Okay, Bill never defined what numbers are, one fellow says. Yes, I did. In fact, I had a couple of videos on that. Anyways, the number is to count. That's what, it's a verb. The word number is a verb. It's not a noun like it is in ordinary speech or in mathematics. No, number is a verb. Verb means that you're going to move your hand up and down and you're going to count. And you count 1, 2, 3, 4, 5. You got a number 5. 5 means you count it, you move your hand 5 times. That's what a number is. We're done. See how simple it was? Number, the verb to count. Okay, it's a verb. And people think it's a noun. They got that from ordinary speech also. Okay, and final issue, fellow says, physics is a science that studies matter, its fundamental constituents, its motion and behavior through space and time, and the related entities of energy and force. Yeah, he copied and pasted. And so he never analyzed it. He doesn't even know what he's saying. He just copied and pasted, okay? That's the way people are. They think it's poetry. They memorize these things and they just recite it. You know, like counting beads on an abacus, on a rosary. Okay, so what are the problems? Well, first the word study, okay? Study does not mean understanding. As I showed at the beginning of this lecture, I studied an orbital for a long time. I still don't know what it is. So you came to the wrong place today, okay? I wasn't able to educate you because I don't know what an orbital is. Can't move through concepts. The guy says it's motion and behavior through space and time. Space and time are concepts. You don't move through concepts. You can move through walls, maybe you can move through water, maybe through air, but you can't move through nothing. Okay? When you move through nothing, it's very scary. Okay? Try not to move through nothing. Okay? No such thing as nothing. So you can't move through it. Okay? You can't cut nothing in half. Okay, energy is not an entity. Okay, and neither is force. So again, you can't move through space, time, force, and energy. Okay, and so we can't study things, entities known as energy and forces because neither one are entities. Entity is a physical object, an object. Okay, it's a thing, and energy and force are not things. Okay, force is a verb, and energy is a verb also. It's an undefined verb. We still don't know what energy is. According to Mr. Richard Feynman, he says nobody knows what energy is. I agree with him. Nobody knows what energy is. I don't even know what energy is, okay? So don't ask me. Entity, what is an entity? A thing, that which has shape. And physics, rational explanations of mechanisms, not the study of. In physics, we do not study. In physics, we explain. With that, I'll see you on Sunday.